Hi everyone, my name is Vineet, and in this tutorial we're gonna talk about how to find sum of two singly linked lists. So let's get started. Now this is our first singly linked list with 4 nodes, and this one is our second singly linked list with 3 nodes, and we're gonna perform addition operation on these both list elements. So after performing the addition operation, we will be having a newly constructed singly linked list, right? And now let's use these elements and perform addition operation. Now you can see these are the elements of first singly linked list, that is 2, 5, 9 and 4. Likewise 2, 5, 9 and 4. So the same way we have another element of second list, that is 7, 3 and 4. So here 7, 3 and 4. Now let's add these elements. So 4 plus 4 is 8 and 9 plus 3 is 12. We have one carry. So 7 plus 5 is 12 plus 1 carry will become 13, and again we have 1 carry. So 2 plus 1 is 3, right? So the final result is 3, 3, 2 and 8, right? Now you have observed, right? We have done this addition operation from right side to left side, from here to here, right? Now it means we were traversing from right side, means from end of singly linked list towards head of singly linked list, right? But if we are when we are implementing this approach in the backend code, at that point we will be facing issue, right? Because our head pointer will always point to first node of singly linked list, and we were not able to access the last node directly, right? And we were not able to traverse from last to second last to third last to first, right? We always have to traverse from first node of singly linked list towards to the last node, right? So, and if we are start traversing from first node to last, right, so that will have different result. See, here we have 2, 5, 9, 4, right? 2, 5, 9, 4, and another one is 7, 3, 4. This is second singly linked list elements 7, 3, 4. When we add from left side to right side, so let's add these nodes together. So 2 plus 7, right, it will become 9. See, 2 plus 7 is 9, and now 5 plus 3, it will become 8, right? 5 plus 3 is 8. Now 9 plus 4, right, it will become 13. So 9 plus 4 become 13. So we have one carry. So carry we're gonna add with another addition. So 4 plus 1 carry will become 5, right? Now you can see when we have done addition from right to left, we have this value, right? Sorry, when we have done addition from left to right, okay, at that time we have this result. And when we have traversed and done addition from right side to the left side, means from end to first, then we have this result. So this is not an expected result. The expected result is this one, right? So for that, what we have to do here now, while implementing this in backend, we have to reverse these both lists, so that we can start implementing adding these elements from here. Okay, when we reverse this list, it will looks like this. See, this is the first singly linked list in reverse order. So 4, 9, 5 and 2. This is reverse list. Now the second singly linked list we have reversed, and the elements are 4, 3 and 7, right? Now let's perform the addition operation on this list. So 4 plus 4. Now, but we will be doing addition from now left to right, means from first node of singly linked list to the last node of singly linked list, right? So let's add the first node of both lists, right? So 4 plus 4 will become 8. See, it will become 8. Now 9 plus 3 is 12, right? So 9 plus 3 will 12, and we will be having one carry, which will be adding while adding the elements of next nodes. So 9 plus 3 will be 12, and we are adding 2 here, and the remaining carry we're gonna add with these elements addition. Now 7 plus 5 is again 12, plus 1 is 13. This one is carry. Now this is carry, which we have added with these values. Now this result will become 13. Now again we have added 3 and 1 carry we're gonna add with the next addition operation. So 2 plus 1 carry will become 3, right? Now there is no any node next to these nodes, so this is the last node and the reference of last node is pointing to null. So this likewise this node which has data value 3, the reference of this node will start point to null, like this. So, and this is a basically addition result, right? But what is the expected value, which I'll show you, right? So expected sum is 3328, but here we have 8233, means this list is in reverse order, you can see, right? But we are expecting 3328. So when we reverse this list, then only we will be, our output will be matched with the expected sum, right? So let's reverse this list, reverse final list again. After performing the reverse operation on this list, we will be having the final reverse list is like this. Now you can see we have these elements 3, 3, 2 and 8. So that is what we were expecting, right? So see, 3, 3 and 2, 8, 3, 3, 2, 8. So means whatever we were expecting, that is that we got after performing the reverse operation on final list. So this is a small graphical representation discussion. Now let's get started with backend code. For that, I have already created a class with name linkerListSum. So inside this class, we're gonna write couple of methods which will be helping us to perform addition operation on both of these singly linker list. So now let's write down the major steps which we're gonna perform as a part of this tutorial. So these are the 3 major steps. The first step is reverse both singly linked list, and the second one is perform addition operation on both of the reverse singly linker list, and the third one is reverse newly constructed final list, right? Now let's get started with first step, that is reversing of singly linked list. Private node, so node is the return type of this method, and the method name will be reverse, which will be expecting input of head of node type, node of head, right? Now the reversing of singly linked list we have covered in our previous tutorial. You can go to my linker list playlist and search for reverse a singly linked list, right? So in this tutorial I have explained each and every line, why we are using pointer, what is the use of that, how we are reversing the singly linked list, what is the scenario when there is no any when there is the value of perform reverse operational, right? So you can go to this video and watch each of the line of the this tutorial. So as a part of this linker list sum tutorial, I'm gonna just write the reverse logic, right? I'm not gonna explain more about this method. So now let's create pointers here. Node of one will be previous pointer, previous, and another one will be next pointer, right? Now what we have to do, we have to use write while loop, and we just need to check whether head is null or not. Objects dot, if it is non-null, then we're going to perform the remaining operation. So let's create head first. So head will be node type. Okay, now what we have to do here is we have to preserve the link, right? So head dot get next. What I'm trying to do here is, I'll tell you, 10, 20, 30, 40, and let's see, null. So now this is the first node, right? But after reversing of syncly linked list, this node should become last node, and instead of pointing to 20, it should start pointing to null, right? And this node is last node, so this node should become first node, and instead of pointing this reference to null, it should start pointing to backward, means data which has value 30. So now we have to reset this link between 20 and 30. Now what I'm going to do here is, I'm going to preserve the link which is pointing to 20, because if we are not preserving this link, then we will not be able to access the remaining nodes, right? So before performing the before breaking the link between 10 and 20, we need to preserve the link of second node, right? So that is what I'm doing here. Now I'm breaking the link of head dot set next to previous, right? So head is this one, head is pointing to this node, so head dot set next means we are resetting the reference of this node to previous. So previous is right now null, means 10 reference will start pointing to null. Now there is no any link between 10 and 20 up to this line, right? But we have next pointer which is pointing to this node, second node, means we have reference to access the remaining nodes. Now we have break this link. Now what we have to do, we have to move previous pointer wherever head is pointing, right? So previous it was pointing to null before, now it start pointing to wherever head is pointing. So head is pointing to first node of this list. Now we have to move head wherever next is pointing. So next is pointing here, right? Before breaking the link between 10 and 20, we have assigned next to this, means we have preserved the link of second node. Now we are assigning head to wherever next is pointing. So head was pointing here before, after this line head will start pointing to this, right? And in next iteration we're gonna move next one step forward. I mean, we're gonna preserve the link between 20 and 30, then only we will break the link between this, and 20 will start pointing to 10, and then we're gonna move previous wherever head is pointing. So head is pointing to this node, right? And then we're gonna move previous, right? So this is all about this. As I told, I'm not gonna explain more about this reverse linked list, right? But I guess you have idea what we are going to do here. Now after once we are exit from this loop, so we have to reset head to wherever previous is pointing. So we have reinitialized the head to previous, right? Now we're gonna return head back to caller method, return head, right? So this is the reverse operation. This is the first operation, right? Now we're gonna perform the second operation, addition of both of the reverse syncly linked list. So second one is private, and it will also return node, right? Node, and method name will be sum. So this sum will be expecting input of head of node type. So as we discussed, we're gonna add two list, and we're gonna construct new list. So let's pass here two list, head 1 and node of head 2, right? So what we have to do here is we have to use while loop. We're gonna check whether objects dot non-null of head 1, if head 1 is non-null, or this head 2, right? So objects dot non-null of head 2, sorry, I have to change this head 2 name. Okay, if it is non-null, then we have to get the value of current node. So for that we have to create two new variable. One is h1 data, or we can say current data, right? Current data. So we have to check whether this head 1 is null or not. So we're gonna do same thing here again. If it is non-null, we're gonna get the value from head 1 dot get data. If it is null, so we're gonna return 0, right? Now the likewise we're gonna do for another list also, means this head 2 also. If it is non-null, then get the value from current node, else will be returning 1. So this is data node 1 and this will be data node 2, right? Now we have to add these two value, because as we discussed here, right? Sorry, not here, right? Now we have reversed both of the list. We have to add these values. So 4 plus 4 is 8, right? So whatever value we will be getting, we just need to add. So here we have extract 4, this 4, right? 4, and here also 4. So we, current data 1 we have 4 and current data 2 we have 4. We have to add these both. So we'll be having current sum int current sum is equal to current data 1 plus current data 2, right? Now what if this value is greater than 10, greater than 9, means 8 plus 4 is 12, right? So we will be having carry, right? So on next iteration we have to add carry here. Let's say in first iteration we have this value as 12, so we have added 2 here and 1 is carry. In next iteration we have to add carry with this values, this sum, and we have to use that carry. So let me add another variable for carry, right? Initially that carry value will be 0, right? So now we have done addition on this list. So 4 plus 8 plus carry value 0, it will become 12, right? Now in current sum we have value 12. So the next step is we have to divide this current sum by 10. So current sum divided by 10, we will be getting carry here. Oh, there is no carry, right? Means if we have value 12, then we are dividing it with 10, right? And we will be getting carry 1. Alright, now we have to get the last digit, int of last digit, right? That will be how we will be able to extract. So current sum, now in last digit we will be having the last digit of this one, sorry, this one, which is 2, right? Now we have last digit, we have carry is 1, last digit is 2. Now we have all the values, right? Now we have create new node, new node, and this last digit will become data of newly created node, right? Now we have to check whether we have the third node, the third head is null or not, because from these two nodes we're gonna create this third node, right? Third sorry, not node, but third linker list. So we have to create third head, right? And we, before doing the next step, we have to check whether this third node, third head is pointing to null or not, right? So let's check that. So we're gonna check whether objects dot is null. If this is null, so here we have head 3, right? But there is no any head 3, so let's create head 3, node of head 3, and initially this value will be null, and we have to create one another pointer, right, which will be current pointer, which will be keep moving on each iteration. So initially that value will also be null. Alright, now if this is the first iteration, right, if we are iterating this first time, then head value will be null. So if it is null, what we're gonna do here is we're gonna assign head to node, right? We are not setting next to this, but if it is a second iteration or third iteration, so at that time we're gonna set current dot set next to node, right? So the next step is we have to move our pointer, basically means we have to move our head pointer one step forward, both of the head pointer, right? So for that we have to check whether objects dot non-null of head 1, right? If it is okay, if it is non-null, then we're gonna move head is equal to head dot get next, right? We are moving one our head pointer one step forward. Head pointer of first list will be moving one step forward. The same way we have to do for second list also. If second list head, if it is non-null, so we're gonna move head pointer of second list one step forward. What is this? Oh, this is expecting bracket here. So now after this we just have to set the current, we just have to assign the current to node, right? This is what we need to do. So now this is all about the while loop. What when these both nodes, right, will become false, means these both head will become false, right, and this whole condition will become false. What if control will exit from while loop? So at that point we have to check, right? Let's say if carry value is 13, right? So if that value is 13 or 1 or 120, at that time we have to check whether if it is greater than 1, sorry, if the carry value is greater than 0, then we have to create new node, let's say we have created these nodes, right? After performing the sum operation, we have newly constructed a node is something like this, and now we have carry as 4, right? So when we exit from this while loop, we have to catch this remaining carry also, and we have to add that carry in the last node of next to the last node of this list, right? So we have to add 4 it here, and 4 reference should start pointing to null. So we have to check carry as well, whether that has any value or not. So let's do that as well. If carry is greater than 0, right? So we're gonna create node is equal to new node. We're gonna pass carry as data of current node, sorry, newly node, and current dot set next to node. Pretty simple, right? And at last we're gonna return result of this, which is head 3. Right now we have done this, right? So we have done this both of the methods. Now the next part is, let's write main method to test our logic whether it's working or not. So to save the time, let's copy this code from here, right? Creating a node code from here. It will save our time. So this is first, and let's get the value for, sorry, this is the reverse list, but we have to perform a reverse operation here. So we have 2594. Let's create the object of current class, linked list sum is equal to new linked list sum, right? So we have created first list, right? But the value should be these only, so that we will be able to compare the result of this which we had discussed and the result which we will be getting as a part of this output, right? So let's pass the value 2594, 2, 5, 9 and 4. Let's delete this fifth node, and let's create another list. Let's copy this. Now that another list elements will be 7, 3 and 4. 7, 3 and 4. We're gonna delete this fourth node. So this will be first and first. So first. Okay, and let's I think we have to delete this. This one is not required. So we have created nodes, right? Okay, so it should be first dot set next, right? Like this. Now we have created another, should be 2, 2, 2. So 2 dot set next, 2, 2 and 2 here. Now we have created this first list, right? Let's print this first list. print, printing elements of first list, right? So let's do the same for second list. Now we have created print linker list dot display, which will be expecting head of node. So the same way we can do here as well, but here we have to pass second linked list head, right? Now we have two lists, so let's perform a reverse operation. So list sum dot reverse, right? So we're gonna check, we're gonna pass first, it will be returning node of first head. Okay, and we will be printing again, or let's do one thing, let's verify this whether we are getting two lists or not. See, 2, 5, 9, 4, 2, 5, 9 and 4. Another one is 7, 3, 4, 7, 3 and 4, right? So I'm gonna comment this so that it won't create any confusion. Let's not comment. So let's out. Okay, now let's print this again. This time we're gonna pass first head. This is a reversed head, right? So let's check what value we are getting. Now see, so 4 is coming here, 9 is here, 5 is here, 2 is here, right? So let's do the same for list 2. This one will be second head, second head. We're gonna pass first 2. So this is the second list head, and here also we have to pass the reversed head of second list, right? Now let's rerun this, or let's remove this, right? Now you can see both of the lists are reversed. 4, 7, 4, 3, 7. So 4, 3, 7, right? You can compare with this 4, 3, 7, 4, 9, 5, 2, 4, 9, 5, 2, right? So we have reversed both of the lists successfully. Now the next operation is we have to perform addition operation. List sum dot sum. So we're gonna pass first head and second head, and we will be returning new head. So new list head, right? So this sum method will be constructing this sum method will be constructing and creating new list, which we have to reverse to get the expected output, right? So let's print this again to verify what we are getting, and after that let's pass reverse operation again. Let's call reverse operation for new list head. Okay, and it will return reversed second head. We're gonna pass, sorry, it should be new list head, and new list head we are reversing, so it will return reversed list, right? New list, and let's print that reversed new list again. Display dot reverse new list, right? Now let me give one message here. So node, this is the third step. We are reversing the final list again. Reversing the final list, right? Here what we are doing, performing the addition operation. On both of singly linked list, right? Here what we are reversing the second reversing second linked list, right? And here we are reversing reversing first linked list, right? So after performing reverse operation, okay, these are the reverse operation, and here we will be having value okay. So after performing the reverse operation on both of the list, here we have reversed list, right? So here we have display, and after performing, okay, we have to print this. So newly linked list before reverse operation, okay. So same way, newly linked list after performing reverse operation. Okay, that's it. Now let's rerun this. Right, so before performing the reverse operation on both of the list, values are 2, 5, 9, 4, and another list elements are 7, 3 and 4. So after performing the reverse operation on both of the list, the elements are 4, 9, 5, 2, right? That is 4, 9, 5, 2. Another list values elements are 4, 3, 7 and null. 4, 3, 7 and null, right? These are the reversed list. And newly linked list before a reverse operation. So after performing the addition operation, this is 4, 4, sorry, this will be oh sorry, here we have done mistake, right? We have to pass another value, but what we are passing here, newly linked list after reverse, newly linked list after reverse, we are passing, okay, but here we are printing, see, we have done one mistake here. We are getting the same value as we have this one, right? So what we are printing after this line, newly linked list before reverse operation, newly linked list before reverse operation, we have to pass this reference, new linked list head. Copy and paste it here, right? And now let's rerun this. See, so 4 plus 4 is 8. 4 plus 4 is 8. Now 9 plus 3 is 12, and we have 1 carry. So 9 plus 3 is 12, 1 carry, and 7 plus 5 is 12. 1 carry will become 13. Again we have 1 carry. 2 plus 1 is 3. So 8, 2, 3 and 3. So 8, 2, 3 and 3, right? Now let's go here. So this is the list, right? Newly linked list before reverse operation. 8, 2, 3, 3. 8, 2, 3, 3. Now let's perform the reverse operation, because expected output is 3, 3, 2, 8. So when we will reverse this list, then only we will be getting the expected output, that is 3, 3, 2, 8. So let's reverse this final list again, and we should have 3, 3, 2, 8 value. So we have 3, 3, 2, 8. Newly linked list after reverse operation is 3, 3, 2, 8. 3, 3, 2, 8, and 8 reference is pointing to null. So this logic is working fine, and we have done with this video, guys. Stay tuned for another videos. Thank you so much.